All right, let's find ourselves a power series, a Maclaurin series, for this function. You should have the series for these four functions memorized for the BC exam. And we're probably going to use this one. So do you have that series memorized yet? E to the x is a series that's real easy to generate using Taylor's formula, but we just need to have this thing memorized. It's x to the 0 over 0 factorial plus x to the 1 over 1 factorial plus x to the 2 over 2 factorial. This is the rule for the nth term. And this series converges to e to the x for all real numbers of input values. So let's suppose that this function was g of x. G of x is equal to e to the x, which is equal to this series. Well, we're finding a function for f, which is e to the x squared over 2. Think of this exponent as the input into function g, which is our known series. If we put x squared over 2 in for x, where does it go? Everywhere you see an x. So this would be e to the x squared over 2. So all we need to do is input this ratio into function g, or into this series, because then if the input is x squared over 2, then we get e to the x squared over 2, which is f of x. All right, so f of x's series is just this series with an input value of x squared over 2, which means it's 1 plus x squared over 2 plus our input squared over 2 factorial, and our input is x squared over 2, plus our input cubed over 3 factorial, etc. So summarizing, the series for this function is 1 plus x squared over 2 plus x to the 4th over 4 times 2 factorial plus x to the 6th over 2 to the 8th times 3 factorial. Next one will be x to the 8th over 2 to the 4th times 4 factorial. And that's the pattern that continues. X to the 2n over 2 to the nth power times n factorial. So if we write this as a series, looks like it's going to be x to the 2nth power. This then goes from 0 to infinity, all over 2 to the nth power, n factorial. And the interval of convergence is all real numbers, just like the original series. All right, well, I hope that helped.